Hey everyone, welcome to a new type of video on my channel. So after my last video, I kind of fell off from game development. I had no project to work on, it became hard to focus on the hobby while also managing my normal life. However, I wanted to get back into it, so to keep myself motivated this time around, I'm going to be filming these game dev challenges. Here's how they're going to work. I will pick a feature from a game that I want to implement, and then I'm just going to jump in and try to complete it by the end of the video. For these first few, I'm going to keep them simple, but the idea is to start implementing more complex features in the later ones. Let's jump into this first one. So for this first challenge, I want to implement a feature I'm already familiar with to kind of get myself exposed to a new tool. These videos are going to be made using the Godot 4 game engine, which is an open source engine that will be linked in the description. I've spent the last few months playing around with the engine, and it's what inspired me to make these videos. The feature I'm going to implement today is the movement from my FusionFall legacy videos. For this challenge, I'm going to convert a model present in that Unity project over to Godot, and I'm also going to convert the scripts for the movement to kind of match it and feel almost identical. So with that, let's get started. Alright, so I am now here in Godot, and I've started the challenge already, and so I'm just going to fill you in. There I am, and then we're going to move forward together. So I've created a simple environment already. So this is the Godot screen, and over here there's a bunch of nodes which make up this scene that we're looking at. So basically I wanted to create just a simple platforming environment. So I added this ground here. It's just a basic cube, and then I gave it a mesh with a material here. So here's the mesh, and here is the material, just to give it a color to look like ground. FusionFall is toon shaded, so I'm using the default toon shader that is built into Godot. So let's get into it, and the way we're going to do that is we're going to start by making a simple player. So I will eventually go over to the Unity project where FusionFall currently lives to extract that model from there, because I have that model set up in that engine and I don't really want to have to reset it up, so I'm going to try to grab it from there. But for now, let's just get the actual movement working. So what I'm going to do is I'm going to create a new scene up here, and we can create a new other node, and we can add a character body 3D. This is going to be something that we can script and actually move. So over here, it's giving me a little error icon. So what I'm going to do is I'm going to add a collider because it's mad that it needs collision. Or it's mad that it doesn't have collision, so it needs it. So we'll add a collision shape. And then over here, it's asking for what shape do we actually want. So most characters in 3D games are capsules. Some of them are cylinders, but a lot of times they're capsules. So we're just going to start off with a capsule. And until we get that model, I think what we want to do is we just want to bring over a simple mesh instance. So I'll bring over a mesh, and I will make this a capsule. And here we go. We've got a basic looking player. So I'm now going to attach a script. So if I click this add script button, what it's going to do is it's going to ask me where to have the script. So let's just call this player motor right here, and I will eventually relocate this to the proper place, but for now let's just get this working. So what this will do is it's going to create a basic template. It's going to create basic movement for classic movement for gravity games, which is a great stepping point. So I'm going to click create, and then we can kind of jump into this, and I'll show you some of the scripting that needs to happen. Okay, so here we are in the playermotor.gd script that Godot generated for us. So this is the template, and it has a bunch of basic movement options already that are great. So this is a great just basic starting point. Over here, I've opened up the player motor script that I wrote for FusionFall Legacy. As you can see, it is hundreds of lines long, and I'm absolutely not going to be implementing all of this. The reason this is so long is because there's so many different systems that got implemented and had to be worked with. So here we have all of different movement values, movement modifiers, vehicle movement. So there's just a lot of different things going on. There's networking that was involved here. So all I'm going to do is there's this movement function here, and it's still quite long, and I'm not going to need all of it, but there's a lot of pieces in here that I'm going to bring over. So if I just kind of have these scripts up, one of the things that is unique about the FusionFall Legacy movement that this movement doesn't do is it rotates the player to be facing the same direction as the camera. So as the player moves, it's going to always have the forward direction be what the camera is looking at, which I think is a really intuitive way to move. So we're going to go ahead and do that. And basically what I'm going to do here is I'll just kind of code and I'll speed up the coding process, and then I'll walk you through like some of the pieces that I just coded. So yeah, we'll just start doing it. Okay, I'm back with an update of how things are going. So, over here on the temp player, I changed up just a little bit. So I created this model object where the capsule now lives, and I added this little hand here just to kind of help me know which way's forward. Over in the environment on the camera, I did end up making this mouse orbit script, right? And so this comes from the FusionFall mouse orbit script. So give me 1 second and I'll pull that up. Okay, so here is the FusionFall mouse orbit script. It's also huge. I went ahead and grabbed some of the most essential parts and just made it into Godot. I don't know if this is the greatest mouse orbit script. It's one I personally just copied off the internet years ago when I made this. So who knows where this comes from, and who knows if this is good, but I copied it over and I think it works. One thing I don't love about it is it needs to know what target it's looking at, and then in our player motor script, we also need to know where the camera is, and so that's what's called a circular dependency. It's usually bad practice, but we're not going to worry about it today, because if I go ahead and hit play in this environment, what you will see is we have a fully movable camera in our environment. Our player can jump oh so tinily, and it has a very, very floaty jump going on. So we can't actually jump on top of any of these things, but we are moving, and if you can tell, we're rotating. So when I move the camera, and I hit W, this is the new forward direction, right? So the player rotates, and the forward direction for the player is always wherever the camera is looking. So if I hit the S key to go backwards, that's coming towards the camera, because that's what determines the relative direction. Okay, so next thing to do is to improve this movement to make the numbers feel a little bit better. So I'm just going to straight up copy the numbers that I used in Legacy, and let's see where that gets us. So one of the things I'm going to change about the script, so I added the different rotation abilities, the rotation towards the camera and the actual model rotation here. One thing I'm going to do is I am going to change how jumping and grabbing are handled. So I'm going to comment those out for now. And what I'm going to do is I'm going to create a jumping function. This jumping function is just going to do what this does, but what I want to do is implement something called Coyote Time. Coyote Time is this idea in platformers that even when you start falling, you still can jump for like a second. So in order for that to happen, we need to know if we can even jump. So can we jump at all? I'll start us off by saying true. Actually, yeah, we do want to start off being like we can jump. So Coyote Time will make it so that when our Coyote Time runs out, we won't be able to jump anymore. We need to check if we are actually jumping. So are we currently jumping? The player does not start out jumping. And we also want to know if we are currently on our Coyote Time. Okay, so we will have those 3 values here. And now I can finish writing this jump function by saying we can no longer jump because we are now in the midst of jumping. And I will say that we are now jumping. So we can no longer jump and we are jumping. So this will be useful for the actual Coyote Time. So I think another thing about it, the way that gravity is being handled is actually exactly how I would do it. Down here is we want to check if we can jump. So first of all, if the input.isAction just pressed the jump key, okay, which is specified by the Godot engine, and we can jump, this is the minimum requirements to call the jump function. So here we go, we can now jump. One thing that needs to happen though is because when we jump, we say can jump equals false, and we need it to be true. We need to be able to reset our jump. So if we can't jump, if not can jump, there we go, and we are on the floor, so we're grounded, and the player is not holding down the jump button. So this is more of a personal preference. Yeah, I can do that. So this is more of a personal preference. I want the player to actually have to release the jump button. If I don't want them to just be able to hold it and then they can just jump forever. They actually have to let go. So jumping is more of a conscious decision. This is one of those psychological game design decisions that was made for FusionFall, and I'm just basing all of this off of the scripts that I had here. But they can be customizable for your own game. So final thing to implement, and then we have all of the movement how I want it, is Coyote Time. So if we can jump and we are not on the floor, is on floor, and we have not started our Coyote Time, we would like to enter our Coyote Time. One thing we're going to need though is the actual timer. So the way I'm going to do that is I'm going to come over here and I'm going to add a timer node. This will just let me, with a script, activate how much time I want to have happen. I'm going to make my Coyote Time 1/4 of a second, but it can be whatever you want. I'm going to rename this to Coyote Timer, and when the timer is done, I want to connect it to my script. The timer is done. That means our Coyote Time is up, so we could we're no longer in Coyote Time and we can no longer jump. And we finally just need to say Coyote Timer.start, which we don't have a Coyote Timer because it needs to be up here. So add on ready var C Coyote Timer. Coyote Timer is a timer. It is going to be Coyote Timer. Is newer. Okay, I'm back in the environment. I figured out just an annoying issue when you use an external editor. So I've got here, as you can see, my jumping and the gravity is looking so good. I'm so happy with it. We can jump around on these different platforms and you can see the Coyote Time. So I'm going to fall off this platform for a second and I'm still going to be able to jump even when I'm falling. So as you can see, I fully get off the platform, start falling. Oh, there, I wasn't fast enough. Start falling, and I'm still able to jump. I have 1/4 of a second where I can still jump. All right, with that done, I'm now going to have to kind of do some investigation into how I'm going to get this model from Unity over to Godot. So I am going to hop over to the Unity project, do some research, probably play around with it a little bit before I show you what I have, and then once it's all done, I will show you and maybe go through some of the setup with you. So let's jump into that.
All right, so I finally figured out how to get the player model out of Unity. So to just kind of big picture show you what the problem was, so this player lives here in Unity that's been imported, and so this comes from a model. However, that model does not actually have any animations connected to it. The animations for the player live here in this folder. So there's hundreds of these animation files, And these files are only readable by Godot. Basically, we needed to figure out how to tie these animations back to the model so that I could use it in Godot. So if we look at this animator, you'll see that the player just has a lot of different animation layers with different animations all connected. And so this took a lot of time to set up, and there's just a lot of moving pieces with all of the different animations going on. Fortunately, I found a really great solution. So I found this GitHub, which is a tool called Unity GLTF. And basically it's an exporter, an importer as well, but I'm using it for exporting, to export Unity as GLTF 2.0, which is an open source 3D model file format. And it is Godot's preferred file format. So I was able to use this plugin very easily. And now, as you can see, I have the player here in Godot. And over here we have all of the animations, the textures were successfully imported, which means all of the UVs here. So here we go. Now I'm just gonna go ahead and set all of this up, where you've got to set up actual materials with toon shading, and I've got to set up the animations that need to loop to make them loop. So I'm gonna go ahead and do that, and I'll check in with you once it's all finished. Okay, so we have the female player here in the actual player motor object, but what we need now is we need to tie the animations together. And so Godot has what's called an animation tree node, which lets us kind of chain animations together, and we can do a lot of really powerful things with the animations without ever having to enter the code. So we're going to set up an animation state machine to kind of get this player to animate according to how we are actually moving. So I'm going to use the Unity project as a reference. So hopefully this will go really smoothly and we can get it on our first or second try. Okay, so I think you probably saw a lot of me hooking up the animation tree all together, and I think it is looking pretty good. So let's take a look at what exactly I did to get all of these animations up and running. So there's a couple of really, just a couple of basic ones for basic movement, right? So you have the idle, what the animation is doing when there's no movement and the player's just standing there. You've got actual movement, so what does the walking or running animation look like? Then you have falling, so when they're falling through the air, you want a special animation to be playing. when they land on the ground, there are two different animations. Either they just landed, or they landed and they are also moving at the same time, in which case those go to a different one. So we can either just land and go back to our idle, or we can land and then start moving. And then there's jumping, which is unique. So jumping, then we've got, from jumping, you can either jump onto the ground, which would then cause you to land, or you can then just fall. And by default, as soon as the jumping animation is finished, you start falling. Otherwise, you will go into one of these transitions. So the way I set these up is we have these expressions here, which are really convenient. So this is just a way to script some different transitions without actually having to enter in the code very much. So very little of these transitions are actually hard-coded, and I'll go into kind of which ones were and not. So here, basically, to go from idle to running, all you do is just check if the linear speed of the player is greater than some arbitrary value, and then just make sure that they're not, and make sure that they are on the floor. And then it's just the other way for going back. So let's take a look at how this looks. So here we go, we've got the player. I tried to fix the shadows just a little bit, but it still looks very strange. So lighting is off, shadows are off, but that's not really super important for this challenge. So if we start moving, you will see that the player is doing the run animation, and we've got our 360-degree movement at the locked angles because I'm not using a joystick, I'm using keyboard input. If we jump, we will enter the jumping animation. So we can do that, and you can see we do the landing animation and go straight to the idle. So now let's do it while we're running. So if we jump, we will do a land run animation and go straight into our running. It's a very subtle change, but it actually is very significant. If you don't have this like land running, or even if the transition isn't smooth enough, it does look really jarring. So one of the things with animations, you can either do this with the actual animations you have to have smooth transitions between them, or you have to be really careful with when you're setting up the animation tree, how you're doing these animations. And just last thing, so if we just fall off, you'll see that we enter the falling state. So that is just something that can just happen to the player. They just start falling. And yeah, so I think that this is it for the challenge. This completes what I set out to do. We have FusionFall movement here in Godot. We've got our player with animations. It is feeling good. It is kind of looking good. We've got some lighting and shading issues, but that stuff takes weeks to months to polish. So for now, I think I'm going to call this good.